All right. I have visibly aged during the course of this lecture. My hair was dark brown when we started. I will say this is actually one of the longer lectures that I give in class. So, chapter 16, part 78, no, part 5, talking about fluvial erosion in rivers. So, we're going to finish up here. We're on the idea of base level. So, we were talking about this idea that rivers start up in the mountains, right? They flow from high to low. Water flows downhill. I know it's a hard concept, right? So, at the bottom of the hill, where do rivers stop flowing? We talked about what's called base level. So where the river ends. So the Chicago River doesn't end at the ocean, does it? The Chicago River ends in Lake Michigan. So Lake Michigan is the base level of the Chicago River. So the base level can vary. So sea level is the lowest one, right? But there can be other ones. If a stream flows into another stream, the Missouri River flows from Montana all the way down to Missouri, where it enters the Mississippi River at St. Louis. That's its base level, where the Mississippi River ends in the Gulf of Mexico, sea level. Now, this can be also risen, so a dam. So, if a beaver builds a dam across a creek, that actually will raise it. Or if a rock slide falls into a river and blocks it, creates a natural dam. And we also do that artificially, which is called a reservoir, right? So, a dam, we build a barrier across the water to stop it from flowing, and the water backs up behind it. That is the new base level. So when that happens, it creates a lake behind the dam. We call it a reservoir. And we're going to talk more about why that is done in a little bit. But when a stream reaches base level, it also stops because it's gone downhill as far as it can. And what happens when streams stop moving? We talked about this. All the sediment drops out. So when a stream enters the ocean, like the Mississippi River or the Nile River, all the sand and mud and dirt that was in the water, it gets dropped out at the mouth of the river. And oftentimes it forms a delta. Okay? And what happens is, as the stream stops moving when it enters the water, the sea or space level, it drops all the sediment out, which blocks the river. So the river flows around it. So it forms new channels, which are called distributaries. So it looks kind of like this. This is a delta. Water is coming down from the hills, from the mountains. Here's its meanders, and here it hits the ocean. Its base level. It stops. And as it stops, it drops all of its sediments. And over time, it builds up right here off the coast, and then will eventually rise up. And this is the top of the delta. A lot of it's here underwater. But the river has to kind of break around it, so it can all these distributaries. Now, the name delta actually refers to its shape. Delta is a letter in the Greek alphabet that is shaped like a triangle, and they call that an accurate or arcuate delta. It's kind of a triangle. So if you were to imagine, here is one side, there's one side, and one side. So roughly a triangle. That is how we actually get the name. But that's not the only pattern. Another one we see is called the bird's foot. And this is the Mississippi River Delta in the Gulf of Mexico. And it does look like a bird's foot. So a little bit more differently shaped. Now, how big can deltas get? Well, it depends. It depends on one, how much sediment, how much fuel do they have, how much dirt do they bring down. But a second thing is also the currents. So, for instance, the Amazon River is the world's longest and largest river, but it has no delta because where it enters the Atlantic Ocean, there's a very strong current. So, all the sediment that it would drop gets swept away. Whereas the Nile River in Africa does not have this problem and has a huge delta. Now, this is actually something, subsidence, that happens in New Orleans. So, what happens is this: as the delta is being formed, as the river is dropping that sediment, right, it's kind of wet, it's muddy. But what happens to mud when it dries, right? The water kind of dries out of it, it shrinks. So deltas build up, but then as they dry out over time, they shrink. And this is actually why New Orleans has been sinking for 200 years. It's built in the Mississippi River Delta. Now, the reason that deltas don't normally go away is naturally every year there's more mud being brought down, new sediments. Okay? And so what happens in the case of New Orleans is we'll talk about we've done things to change that pattern, and it's not keeping pace naturally. And that's why the vast majority of the city of New Orleans is actually 8 feet lower than the ocean that surrounds it. And that's what we call anthropogenic or man-made subsidence. And what happens is we don't like floods. So as the city of New Orleans grew, they built these big, huge flood walls along the river called levees to keep the river from flooding every spring. What happens is that flooding also doesn't allow it to replenish that sediment. It's pushed further downriver. And so in New Orleans every year they'd have a flood, but that would keep the delta from sinking. So what happens is it gradually sinks because we kind of starve it of that sediment. And as it sinks, the sea encroaches. So here, right here is an example. This is New Orleans. This blue line is the Mississippi River. Here is the current mouth of the delta. You can see the deltas move throughout time. It's been over here, it's here. And what happens is it goes this way, it fills up, then it flows this way, all around. It can kind of move over thousands of years. But what's been happening for about the last 200 years is all along this stretch right here through the city, they've built these huge flood walls. And so now, every year when it floods, instead of covering all this land with new dirt, it doesn't. And the dirt gets pushed way out here to the Gulf of Mexico. And in the meantime, this dries out and it sinks. Now, as this sinks, you can kind of see this here. This almost looks like faded. These areas used to be much thicker. And now they're sinking and the sea encroaches on it and floods it. And another thing that happens is, as it gets further inland, the plants that don't like seawater die off. And just like we talked about, if you remove the ground cover, it makes the ground easier to erode. And so it's kind of a double whammy. One of the problems with New Orleans is it's not only lower than sea level, but the land used to be all the way out here, which made a really nice natural buffer during hurricanes. When Hurricane Katrina hit, it could go much closer to shore with water, which is why there was more severe flooding. Which brings us to our last topic, flooding. So, a flood is basically what you think it is. Any area that is covered by water, not normally covered by water. So if you are in a region that is not normally covered by water, but something happens, it's a flood. It could be 2 inches, it could be 20 feet thick. It doesn't matter. Okay? Now, floods are 2 types. Flash floods happen instantly. So usually after a huge rainfall or a dam burst, something where the water floods right away, like in literally minutes, sometimes in seconds, but definitely within a day. Or seasonal flooding. So every spring, areas in mountains, the snow melts in the mountains, and all that snow melt goes down the river, and the rivers rise. Or there's a rainy season, as in India or Vietnam, where the rivers rise in the rainy season. Okay? Now, flash floods happen, oddly enough, in the driest areas. They're very common in Nevada, in Arizona, in the high deserts. And why is that? Because these areas are dry year-round. They might have 1 month of rain. So, for instance, in Phoenix, Arizona, it's dry almost year-round. They get a really big thunderstorm, and all of a sudden the dry riverbeds fill up for a day, instantaneously, flash floods. Seasonal floods, even though they're actually larger and happen on a regular basis, makes them safer. Because one, they happen slowly. So they rise in the spring and they sink back down in the summer. But it's also regular. We know that every spring the Nile River floods. And you know where it floods. And so in South Asia, for instance, this is very common because, especially in the areas near, say, Thailand or Vietnam or India, they don't have a winter or summer, but they have a wet or dry season. So take a look at this picture. This right here is in Thailand. Here is this river, and you can see all these farm fields and some city areas. This is normal dry season, and you can see all the floodwaters in the wet season. So this area floods. It's a vast area, but there's very little loss of life because the people that live here, they know that. So they build their houses on the high ground that doesn't flood. This is all farmlands, so it doesn't matter if it floods because once the flood drains away, it's left a nice thick layer of fresh mud, which is tons and tons of fertilizer. Or a lot of some places, like in the Amazon, they build their houses on stilts so that they're dry, if on an island, if you will, but they're not flooded out. And this is a regular, predictable occurrence. Now, there are some ways to manage floods. So people do that. And one of the ways we do that is by building dams. So one thing a dam does is it holds the water back. So if you build a dam on a river that floods every spring, you can basically stop the flood here behind the dam because you decide how much water comes out. And what happens is the benefit of that also, by the way, is now you have this big lake of water behind you which you can use. So they do this, say, in the desert. They have a dam on the Colorado River called the Hoover Dam. The big huge lake here is a reservoir which they can use for drinking water for Las Vegas. But what are the disadvantages? Areas downstream, natural habitats that have evolved with a spring flood now no longer have that. Like I showed you before, the Colorado River is actually dry by the time it hits the ocean. Not only that, when this water hits that dam, it actually stops moving. So it drops the sediment. And sometimes reservoirs will fill up. And the last thing is, if there's a problem, this dam could actually fail, and all that water would go rushing down, and a flash flood could happen, which has been severe. There was a flash flood in Pennsylvania in the 1880s, which killed thousands of people. Another management tool we've talked about are levees. These are basically long, thick barriers along the edge of a river, kind of like a dam on the sides of the river. And what happens is they're very easy to build and they keep all this area dry. But when they do fail, large areas flood. And the other thing is, it actually makes floods worse because instead of letting them spread out and dissipate, they get channeled. And what happens oftentimes is that when they do break, the water is even higher. The last one is a stream bypass. So this is actually built around New Orleans. We know that the river floods down in Louisiana every year. They have these dams or levees on the sides of the river they can open like a gate. When the water gets too high, they open this gate and they channel the floodwaters to a path around the city. So it's kind of a levee that's basically fails when you want. It's a pretty interesting way. Problem is, it's very, very expensive. So with flooding, you have these ideas of risk, right? There's the annual probability. In fact, so at any given year, what is the probability of a flood? So if you live in New Orleans or you live in St. Louis on the Mississippi, you can say your probability is 60%. That means that in any given year, you have a 60% chance of a flood. We can actually measure a flood itself, how big it is, with this idea of recurrence interval. If you've ever heard the term a 100-year flood or a 500-year flood. So when it comes to floods, you've heard of the idea of a 100-year flood. This is the idea that basically the flood that you're experiencing, how big is it, how severe is it, is the kind of flood that would only happen once in 100 years. That's a pretty severe flood. A 500-year flood would mean it happens on average once every 500 years. Now that doesn't mean you can't have two 100-year floods back to back, just the odds would be pretty low. And that brings us to our last section, talking about this idea of dams. So the good and the bad. So dams have increased. This map here in the 1850s, each blue dot is a dam on a river. And you can see that throughout our history, it's added there are many, many dams. Not all of these dams are large and huge. Some of them may only be a 2 or 3 foot tall concrete barrier across a small creek. If you go out to the Des Plaines River, out in the forest preserves on the west side of the city, there are 7 or 8 dams on this river that are very small. They can be large, like Hoover Dam, and be 20 stories tall. So what are the good parts? Well, if you build a dam on a river, you have a big, huge lake behind it. You can actually store that water that would normally flow away so that you have water year-round for drinking. And in doing so, you reduce the risk of floods. Another thing you can do with dams, is you can run the water through the dam and it will turn a turbine and make electricity. And the beauty of this is this creation of electricity does not burn anything, so it doesn't release any carbon, so it's very clean. And the last thing is that long big lake you build behind the dam, the reservoir, makes it easier for boats. And so some rivers are too dry to have shipping traffic in the summer, but the dams allow that to happen. And you can actually ship goods by barge from New Orleans all the way up to South Dakota on the Missouri River. And this just shows you, here's an example. This is the discharge of a stream right here in 1994. And the green is the same stream in 1942. So every spring, April, May, June, it would flood. But with this dam, now it's pretty much steady year round. And all this water that would have flooded is now being held behind the dam so that here in the dry summer months, you have water to use. This is how a dam makes electricity. You've got your dam blocking the river, the water fills up, you put a little hole in the bottom, the water shoots through it, comes through the dam, turns these turbines which make electricity. So that's the good part. What are the bad parts? Well, reservoirs fill up. Here's a dam right here. But remember that when you build a dam, you stop the water moving, so it drops its sediments. And this valley over time filled back up. So now it's the same level as the dam. So now this has become basically a waterfall, and the dam is useless. So dams have a life. They are not forever. Eventually they will fill up with sediment, and then they become useless. And then what do? You really can't do much about it. You've lost the ability of it. Second thing is, the water that forms behind it, the lakes, can flood cultural significantly sites or habitats. In the Colorado River, there's a dam here that made Lake Powell that flooded many ancient Native American villages. So these are now gone. They can't be really explored too much. Also, habitats in here. Riverline shoreline habitats for animals were destroyed when the water rose. In China, they built the largest dam in the world on the Yangtze River, and several small villages and medium sized cities had to be evacuated. People were told to move and then lost these communities. We also find it interesting that climate change, a large body of water on a river becomes a lake, can affect the local climate. Just as we talked about, Lake Michigan makes us cooler in the summer and warmer in the winter. The extra water can also make areas in the tropics extremely more humid, all that water around. And that's not always a great thing. So, as always, you got to take the good with the bad. We do find this large new dams, they call those hydro projects, in developed countries like the United States or England or Germany aren't likely because we are more concerned with the environmental and societal costs. In fact, a lot of dams have been removed. There was one dam on the Chicago River up by northeastern Illinois. It was right near Foster. So the dam on the Chicago River was right near Foster. Very short dam, and it was built there in the 1940s, I believe. They took it out 2 years ago. They felt it was better for the environment, and we really didn't need it. But that being said, in developing countries, we see dams being built. So, China, for instance, built the world's largest dam recently because the electricity this dam would build and the water it would provide and the floods it would save, it was felt that would far outweigh any negative costs. So, what does the dam look like when it comes out? This is interesting. This one right here, this is over, I believe this is in Washington State. They're literally just cutting the dam out. You can see the water's going right through. Another aspect we didn't talk about, and a little bit, is fish. When fish migrate up the river, like salmon are born in a river, they swim downstream, they live in the ocean, they get nice, big, and fat and tasty, and then they swim back up to where they were born. They can swim over waterfalls and rocks naturally, but they can't swim over a dam. So a lot of streams in the West, they built these dams. One of the unintended side effects was the population of fish dramatically dropped. So that's one of the reasons why they're taking them out, because the benefits of fishing and natural wildlife restoration is felt to be stronger. So anyway, that's all I got for you guys. I know this was a long one. Feel free if you have any questions to email me. Go back and look at the lectures, and you always have your book to read as well. So I will see you guys in the next chapter.